Hi, everyone. Welcome to the Scaling CI/CD in your enterprise with an internal Spinnaker as a service session. I hope you're enjoying the rest of the Spinnaker Summit, and I'm glad you can join us today. My name is Balaji Siva. I'm part of the OpsMX team. I run products at OpsMX. I've been part of the Spinnaker community for the last 4 years. I've seen the growth from where it was about in 2016 now to today, and it's great success. And I'm joined today from OpsMX, Gopinath Rebala. He's our CTO. And Gopi, why don't you say hi?
Hello, everyone. Thank you for joining us today.
And Gopi, by the way, has been along with us in the journey, and he has supported many large Spinnaker deployments with our clients. And today we hope to share with you how you can set up your own internal Spinnaker as a service for scaling your Spinnaker in your enterprise. So I'll give you an introduction of what that means. Spinnaker as a service may be confusing for some people. I want to give you a quick overview of what I'm talking about. And then Gopi will get into how you would do, how you set it up, how to implement it, and give you the best practices. We'll also cover a couple of real life use cases where customers actually try to do this internally and had success. So before I get started with the actual Spinnaker as a service, Spinnaker is widely used for a lot of different use cases. And one of the use cases, obviously the primary use case is people look at Spinnaker because they want to look at multi-cloud deployments. They're going to Kubernetes or containers, or they're adopting public cloud, and they look for a unified CI/CD tool that they can leverage. The existing tools may not scale or may not work for the new model. So that's something that Spinnaker is a great use case. So one of the main use cases around orchestration. How do I do end-to-end orchestration of container and VMs and serverless deployments? And Spinnaker provides you across multiple platforms. There's also emerging use cases around infrastructure updates as part of Spinnaker, as well as updating big data platforms or databases, schema changes, etc., as part of Spinnaker. So I did a session with Cisco last week around this emerging use cases. So if you haven't seen it, please take a look at it. All of these use cases essentially are derived from different groups within your companies, within your enterprise, and you would see that as you start scaling your Spinnaker within your enterprise, you would need to address many of these use cases to really go enterprise-wide. Typical enterprise architecture obviously starts off with something like this. You would set up an active and a standby Spinnaker instance. Spinnaker, by the way, is multiple microservices. So you have essentially two different clusters where you would deploy your active and a standby Spinnaker. These are typically deployed across multiple availability zones so that you have availability available for you. And also you would set up shared databases. But if you have an active Spinnaker failure or a cluster failure, you have a standby able to take it up. So you have obviously two databases to worry about, pipeline config data, as well as a pipeline execution data that you would set it up shared across these two instances of Spinnaker. And with these kind of setup, you can get a 99.9% of availability uptime. So you can obviously tweak it further to get higher availability factor. So people typically set up Spinnaker as a code and to ensure that they can have a repeatable and traceable deployment. This is sort of a standard thing you would do. Now, what happens after, let's say you have done this for a single group, if let's say you're part of the enterprise IT organization, you set up for yourself or set up for your group, and then as you start getting more and more requests from outside of your group, you start looking at how do I expand it beyond this? And is this the right architecture going forward? So, a number of reasons you would go, like I said, one is to scale up. Now you have more people, more groups trying to use Spinnaker. So you need to look at how do I scale up my Spinnaker setup beyond my group, right, or the central group. And also you would look at, maybe you want to have a prod and a non-prod environment within Spinnaker. What I mean by that is that for dev workload deployments, you have a Spinnaker. And for prod deployments, you have another Spinnaker instance. So you have two Spinnaker instances. Again, there could be active and passive as well, but you have two separate Spinnakers. And also there's another use case for multiple Spinnaker is that you have a staging Spinnaker. So let's say you have a production Spinnakers instances, but then you have a staging Spinnaker so that whatever changes you want to make to the Spinnaker itself, or to test a new feature or new version before you bring it to production, you want to have that. And the most important use case here is a Spinnaker for each dev group. This is when you really scale out enterprise-wide. And we can talk about why do you do that? And number one is that as you really go thousands, 10,000 pipelines, do you really want to have one single instance of Spinnaker managing all of that? So you really look at multiple Spinnaker instances for scale. The other reason is for security or isolation reasons. Maybe there are group-specific policy that makes people want to deploy Spinnaker separately for compliance reasons, or to avoid a shared fate between different groups. You want to be able to have multiple Spinnaker instances. The other use case for velocity. Maybe a certain group is slow moving in terms of wanting new features. Maybe another group wants Istio or other new Lambda support or other kinds of support. And so you want to upgrade the Spinnaker. You don't want to necessarily have the slowest group blocking everybody else from adopting the new features of Spinnaker. So having a separate instance really helps. The other part is around performance. Depending on the instance sizing that you have created, you may have restrictions. For example, with a 32 GB per pod sizing requirement, you may have up to only 500 accounts or maybe 1,000 users. Beyond that, you may be having challenges. So definitely performance, or maybe a globally distributed development team that they want to have India-based Spinnaker instance and a US-based Spinnaker instance. You want to have multiple instances just for that. Another use case that I've seen is about internal billing. So internal billing is that a central group wants to charge back to the internal groups, and they want to have a separate Spinnaker instance so that the chargeback is very clear. So what is Spinnaker as a service requirement? Is, let's say you have this challenge. Let's say you are a group, you are an enterprise listening to this call and say, you know what, yeah, I do see that. I have to have manage multiple instances, have multiple groups looking for Spinnaker within my large enterprise, and I want to do that. So what are the different requirements, and how do I make it easier? So what are the day zero requirements for such a requirement? Is that you need to gather requirements around sizing that they need, number of users, number of accounts, number of pipelines that they need to have. You need to get the SLAs. Depending on the SLA requirements, you may have to set up separate Spinnaker with more high availability need requirements. And you also worry about what kind of integrations that they need, what kind of targets that they're deploying to. You also have to obviously acquire the resources for the actual Spinnaker installations, and then you have to install it. You need to configure all these integrations and their accounts. You need to enable role-based access controls, and you need to enable monitoring to ensure that you're able to monitor the installed Spinnaker instance. And then that's obviously the day zero, where you sort of enable that instance for your end client. And day one becomes, they're worried about how do I onboard their applications onto their Spinnaker instance. How do they enable application templates? So essentially, templates are used to not have to recreate pipelines per user per dev group, service that you're deploying, so you can actually reuse some of the pipelines. So how do I do that? And also, you may have policies. There may be a group level policies that you will need to enable for that instance, or maybe you have a global policy that you're enabling on all your instances. And you need to enable the audit trail because you want to know who did what, not only from an individual group perspective, but also across the whole setup. And finally, on the day end, which is sort of the maintenance mode, you're in a maintenance now. You have all set up all these 10 instances or 20 instances of Spinnaker. Now you need to monitor, make sure that things are not going down. You need to troubleshoot the Spinnaker, and you need to be able to do backup and recovery. And something goes wrong, you need to do backup or you need to recover those instances. And you need to upgrade because there's always a new Spinnaker release coming out every so often. And maybe you need to make some policy changes or best practice changes that you want to apply across all of them. As you look at this, all these set of requirements, you can quickly realize that, hey, this is not an easy business. To be able to do across one instance is great. I was able to do just fine. But imagine if you have to do across these N instances. So we have seen groups come to us and say, hey, I need help. And so what are some of the challenges that they face? Is it's time consuming, definitely, to onboard new groups, new Spinnaker instances, set it up per individual requirements, onboard your applications. It's complex because you're now having all of these instances running. You need to maintain the configuration of it. You need to maintain the availability of it. you need to do all of the requirements we talked about earlier. And it's tedious, essentially, to do this over time with multiple instances, multiple user requirements, it's complex. So that's the problem set. You definitely need to, eventually you would end up in the situation. I've seen customers or enterprises use a single large instance of Spinnaker and maybe okay, that may be good for them. But I've also seen more instances of multiple Spinnaker instance requirement. And so with this session, we really like to provide you some tips or how to implement this multi-Spinnaker instance solution for your internal use case. With that, I'm going to give the ball to Gopi. He's going to talk about how do you implement this solution. Gopi, take it away.
Thank you, Balaji. That was a pretty good overview on enterprises, how they use Spinnaker and the challenges that they face. So what I want to do is take up where Balaji left off with what the scenarios are, how the deployments are being done today, and what general models there are in enterprises that they're deploying, and give some insight into the problems that we face if you want to do Spinnaker as a service in a repeatable deployments and do easy upgrades managing multiple instances of Spinnaker. And we'll look into some of the problems and how we can overcome that, primarily using GitOps models. So as you are deploying the production systems from after you've done the POC, you've done the integrations with your SCM, you've done integrations with some of the tools with the DAST, or for replacing manual judgment, you may have done Jira or purely for notifications. And you've done integrations with their authorizations, which is obviously critical for enterprises, or single sign-on configurations with SAML or OAuth, or 509 configurations with API access. So here, the complexities are, you have to manage the certificates. There are secrets that you have to manage along with all of these. Even setting up the ingress management with your Spinnaker instance, most of the scenarios that we have seen are they're set up as a single time thing. And if you want to repeat that, there are some manual steps that one has to take to do that. So all of this creates complexity in for a repeatable process. And also if you want to have n instances that you're managing, you want to be able to have that as a code that you can quickly with one click go ahead and deploy the thing that is required, which is critical for your upgrades also. As part of this planning, again, you have latency requirements. Some of the Spinnaker services have to be scaled up versus scaled horizontally with auto scaling support that you have set up. And the requirements may change over time as you add more number of users into your system. Now managing these changes, it becomes critical that you have to be able to use it in a simple one-click way. Account management is one of the harder pieces here, primarily because how do you manage the provisioning of new users that are coming in with their applications? You want to be able to do self-service with it. Without the self-service, the IT department gets overwhelmed in supporting their users. You want to have some patterns that are defined with the pipeline templates and give it to them. And now when we do that, how do you ensure that the process is repeatable, backup and recovery happens with the onboarding that users are doing? Usually 60% of the problems in the deployments happen through human error. So that's the primary thing that we are trying to overcome. And the secrets management is another critical piece at part of the deployments. There are a variety of secrets management that is going on with Spinnaker. Today, you may be using Spring Boot-based secrets for individual services, but it's not supported for all the kind of secrets that we use within the Spinnaker. Now, how do you ensure that that process is also streamlined? So when you deploy a new instance or upgrade, you have the same process that allows you to bring up the instance without problems. Now, so as part of this on day zero itself, what you want to do is try to set it up in a GitOps process where you have a Spinnaker config as code in repository that's version that you can deploy. What is the problem today? Right? Today, most of the deployments are done through Halyard. Of course, that's the primary deployment paradigm. And in the Halyard, we saw all these configurations that we had to go through in the last couple of slides are distributed across multiple files. If you're doing air-gapped installation, the bill of material configurations are in some place. If you're sizing, it's in the HAL config. If you have certificates managed for TLS within the services, they are in profiles. And there are some of these configurations that are not supported by Halyard, so you have to set them in profiles. So these are all distributed across different files, and one has to actually figure out where each of these systems go. And then as you deploy, you still have to bring up Halyard and then generate all of these files and then apply them. So this becomes a two-step process with different locations that these files are. And even if you use Helm charts with values, that's not completely supported, and it's one huge values file becomes a cumbersome thing to maintain. And if you have multiple instances of Spinnaker, that becomes even harder. So the process that we followed generally is you have all these configuration files and templates, which you hydrate based on the values that you want to deploy for each one of these instances. And you get the secrets in a secrets database, whichever one that you prefer to use, like a Vault or even encrypted S3, or even Cloud Driver itself, and then apply that to individual services. So today, most of the deployments still use Halyard, but it's fairly close to the system of the customized. If you have seen the CLEAT, how it defines these templates, the secrets, config maps in individual files, and then you would apply directly into Kubernetes, is the kind of a process that we follow that helps us have these templates specified for the groups. You can have these templates based on the deployment size, for example, and generate the hydrated values with the secrets and apply them into your Kubernetes environment and bring them the instance in one click. So advantage of this is having additional templates also is if you have the DNS configurations that you have to do, or you have the load balancers that you have to configure as part of it, that all comes with the system. So other two systems that people use are operators and Spinnaker on Spinnaker as some things that come up. Operators are good, but since they depend on either Halyard-based deployments today, or they have the same kind of issues, they're slightly easier because you can pull operator from Operator Hub and then deploy your Spinnaker. But for doing this config as a code with Spinnaker, you still run into the same issues unless you follow the template form and using the init container for hydrating these and deploying the Spinnaker with it. Spinnaker on Spinnaker works well for VMs, but for the Kubernetes deployment, since it is still doing this two-step process, it's not very useful. Now that you've figured out how to set up these templates, hydrate them with your secrets, apply to Spinnaker services, and have them version, all the change management can be done in one place. This next challenge you get into is this: how do you provision the applications themselves and manage those centrally? Here, we see three different models here. One is there is a central group that's managing the Spinnaker, allowing users to onboard their applications and pipelines. Here, everything needs to be self-service, otherwise the small IT groups generally that manage Spinnaker will not be able to service a large number of applications anyway. So then when we do that, these customizations are different stages in these pipelines. There will be requirements for policies. How do you manage those policies? So here, the three models that we see are pipeline templates that are prescribed by central group with some amount of customization that's possible, but not necessarily adding extensible stages to them. The second one that we do is more interesting one is we deploy Spinnaker instances to individual dev groups. And each of these dev groups have full control on what kind of applications or pipeline structures, they build on them. So here, the central group that's providing the Spinnaker service is primarily focused on deploying the Spinnaker, monitoring the Spinnaker, and supporting the backup and recovery for it. And individual dev groups themselves go ahead and create their pipelines, extensions to the Spinnaker for adding additional stages in them, and all of that. But central group is still responsible for taking the backup and recovering the pipeline structures for these groups. So to this, what we do support is the Git-based process for these pipelines. Spinnaker does support pipeline templates, but here we still have the pipelines that are specified in Git that are assigned to individual instances. So all the pipelines that are there in the Spinnaker are backed up into the Git, and there are specific applications or a group of applications that are always synced with the Git. So what this allows is to ability to have dev groups, certain number of applications that are free to create their own applications, pipeline structures, but some of these applications are compliant pipelines or compliant applications that are managed through the Git process. You can version them and also control when these pipelines get changed and who authorizes these pipelines purely based on the Git process. The second issue is how do you manage the accounts? Here, the main problem is about the authorization. When the users use their accounts, because it's a self-service, then these accounts are dynamic. And there are new clusters that are coming up, and some of the old clusters are going down. So during that process, you have to manage who gets authorized and if the authorization is valid. So for that, there are two models here where the user gives their own secrets based on their secrets, like the kubeconfig. They get access to the accounts that they are provisioning within the Spinnaker. The second one is the IT manages the access. They have a database that they can manage. Based on those database, when the users are provisioning their pipelines and asking for accounts, you would verify using the policy service whether they have access to those accounts and give them access to the application. So given this, we essentially ensure that everything happens through versioned system, and all the pipelines and accounts that are created are all backed up and can be recovered with one click. So here there is a second reason where you want to back up. Also is the Spinnaker, depending on RTO, RPO requirements. If you have very high availability requirements, then you can have an active passive system where the data in the Git is also replicated, and the database itself is replicated. We can bring up the second instance of the Spinnaker. And because with the Spinnaker not requiring very high availability, you can have these configurations on Git, bring up a second instance of Spinnaker in a different region very quickly. Usually you can bring up a new instance from scratch in less than half an hour with all the configurations that are running in the primary system. Okay. So by having the Spinnaker config as code, now what we have achieved is a single click deployment. The change management is very, very simple because you have all the templates. If you're updating a version of the Spinnaker or changing the configuration to use something else, you simply change the config, hydrate the templates, and apply them. You would get a new Spinnaker instance with a new version. So rolling back is critical because there may be changes that are applied that may go incorrect with some of the applications. So the rollback process would be extremely simple because you can just take the previous version of config and apply it. You roll back to the previous version. By using this process, you can also configure most of the requirements for SOC. Right? As you have production instance separated from your dev instance, any changes in the dev, you can go through a simple process of Git approval or admin pipeline that goes through an approval and gets promoted to your production environment. And there's no manual touch that happens in the production environment except approvals that go through Spinnaker. And I'll walk through a couple of use cases quickly, how we have implemented this process. One of them is with the large enterprise organization, they have thousands of accounts. There is an infrastructure limitation where, because of the cloud driver vertical scaling, there are only a certain number of accounts that you can provision within a given instance. So here we run multiple Spinnaker instances by sharding the applications within them. So there are different set of applications run in each of these instances. We run about 8 instances in production, and by simply applying this model from the Git with the templates, we manage these 8 instances with a single click deploy and upgrades, and backup and recovery happens automatically with these. The other interesting one is also if a financial sector enterprise that has a very strict requirements on compliance. They have a dev stage and prod Spinnaker instances. Any changes that they make, everything needs to be tracked. And the changes that happen to prod all has to go through a process with no manual intervention except for approvals. So by simply configuring that system with the Git process, we were able to achieve full compliance with all the secrets management that happens with that. And using the same process, we have set up the disaster recovery across regions. Hope that was helpful. Let me hand over to Balaji for some comments.
Thank you, Gopi, for a lot of information. That's a lot of information. So hopefully the audience is able to get some of it. And I know that we try to cram a lot of things into this particular session. And if you have more questions, feel free to email us at hello@opsonex.com. We're happy to help you and your enterprise with your requirements. And also, if you want to reach us personally, you have our email address here below. You can reach out to us at Gopinath@opsonex.io or myself, Balaji, at opsonex.io. And we'll be happy to answer any questions. Next week, Gopi has another session, or next couple of weeks, I guess. So if you'd like to learn more, please make sure that you attend that as well. And thank you so much for your time, and I hope you're enjoying the rest of your Spinnaker Summit, and hope to see you in another session. Thank you very much.
Thank you.